Hello everyone, welcome you all to this video. So in this video lecture, we are going to discuss a small topic from the application of thermodynamics. So that is the basic difference in between the four-stroke and two-stroke engine, right? So before going to understand the basic differences, let us try to understand first what an engine means and what a four-stroke engine means and what do we mean by a two-stroke engine. Okay. So after getting a overall idea, so then we will be moving towards the differences. Okay. So basically, what an engine means, we will be trying to define an engine. Then this can be defined by a device, right? That means engine is a basically device which will be converting heat into work. That means heat will be provided at the input and work will be obtained from that particular device, right? So heat will be provided and work will be obtained, right? So by any means, if we are getting work by using heat, then such type of device is known as an engine, right? And if we will be trying to understand what four-stroke means, before understanding the four-stroke engines, let us first understand what do we mean by the four-stroke. The stroke simply means the movement of the piston inside the cylinder from one dead center to other dead center. Suppose piston is now at the top dead center. Now it is moving from the top dead center to the bottom dead center. Then this can be called as a one stroke. Similarly, again, if the piston is moving from the bottom dead center to the top dead center, then that is again called as another stroke, right? So simply, we can now understand what a stroke means. So stroke simply means the movement of piston inside the cylinder from one dead center to the other dead center, right? So now let us understand what a four-stroke engine means, right? So simply any engine which will which will be producing the power or work, that means it will be converting heat into work. So this can be done by using a cycle. And the cycle must be consisting of number of processes. Okay. So any cycle which can be completed by four strokes, that type of engines is known as a four-stroke engine. That means in which engine the work will be produced obviously by completing a cycle, and if that cycle is being completed by four number of strokes, that simply means the piston of that particular engine moves four times from one dead center to other dead center, then that type of engines are known as the four stroke engines. Okay. Similarly, if we'll be talking about the two stroke engine, in this case the completion of the cycle, the production of power can be done only with two strokes. That simply means movement of the piston from one dead center to another center happens two times, right? So I think you have got a brief idea about the four stroke and two stroke engines. So let me summarize it. Four stroke engines completes the cycle in four time movement of the piston from one dead center to another dead center. Okay. Similarly, two stroke engines completes the cycle of power production in two strokes. That simply means two time movement of the piston from one dead center to other dead center. Okay. So if we'll be talking about this movement of the piston from one dead center to other dead center, that means if the piston moves two times from one dead center to other dead center, then it will be causing one times of the revolution of the crankshaft. Let me clear it again. So if our piston moves twice from one dead center to other dead center, then during this twice movement of the piston, that is the reciprocating motion of the piston, our crankshaft will be rotating once. So from that we can say that if our four stroke, in case of a four stroke engine, will be doing four reciprocation motion. That means if it is being starting from here, it will be going down, again up, again down, again up. So it will be doing four times of the reciprocation motion That simply means it will be doing 2 times of the rotation motion of the crankshaft. So that is what I am trying to say. So if we will be talking about the two-stroke engines, then in this case there will be 2 times of the movement of the piston. That means this is once and this is once. That means during these 2 times of the movement of the piston, the cycle is completing. That means power is getting produced. So during this completion of the cycle, we'll be having 1 time revolution of the crankshaft. I hope it is understood. So let us move further and try to understand the basic differences. Okay. So now you can see the first difference is that what I was talking about. That is, it has one revolution of crankshaft during the one power stroke. That means when sorry, power will be produced during one cycle, there will be 1 time revolution of the crankshaft. So during this 1 time revolution of the crankshaft, power will be produced and there will be completion of the cycle in case of a two-stroke engines, right? And but in case of a four-stroke engines, our crankshaft should rotate 2 times to produce the power to complete the cycle. Okay. So from that we can understand we are having 4 processes in an engine to produce power. Like already we have discussed about that. So there are 4 processes. What are they? Suction, compression, expansion, and exhaust. Right. So during suction stroke, there will be this is in the case of your post stroke actually. So that means to produce power, any engine should be having all these 4 processes. That means there should be suction, there should be compression, again there should be expansion, and there should be exhaust. Right? So if we be talking about four-stroke engines, all these processes happen during a single stroke. But if we'll be talking about the two-stroke engines, then in this two-stroke engines, one stroke will be doing 2 processes, right? So this is how all these 4 processes get completed during 2 strokes. Okay, I hope it is understandable. Still, let me summarize again. In 4-stroke engines, there are 4 processes to be done to produce power, right? So in 4-stroke engines, each stroke consists of a single process. But in case of a 2-stroke engine, each stroke consists of 2 processes, right? In four-stroke engine, each stroke is consisting of a single process. In case of a two-stroke engine, each stroke consists of 2 processes. Done? Okay. So next difference is that it generates high torque, right? And similarly, in case of your four-stroke engine, it generates less torque. I think it is now understandable. During one revolution of crankshaft, in case of a two-stroke engine, we are getting one power stroke, right? But in case of a four-stroke engine, during two revolution of the crankshaft, we are getting one power stroke, right? So due to that, we can easily say that we will be getting maximum torque in case of your two-stroke engine, minimum torque in case of your four-stroke engine. Okay, done. Okay, next it uses a port of the fuel's outlet and inlet, right? That means for the entry, that inlet and exit of the fuel, there are ports in case of a two-stroke engine, right? But in case of four-stroke engine, there are valves. Okay, so to enter, okay, so for the entry condition of the fuel and air, that may be again only air will be going into the cylinder during suction process if we'll be talking about the diesel engine. Okay, and if we'll be talking about the petrol engine, there will be mixture will be sent into the cylinder, right? Okay, so that may be the different case, but there will be different valves in case of the four-stroke engine, and there will be ports in case of the two-stroke engine. Okay, so let me add something over here. In case of a four-stroke engines, there are valves, right? So for the opening and closing of the valves, there is a mechanism. What is the name of that particular mechanism? That is cam and follower mechanism. Cam and Okay, so this is the name of that particular mechanism by which the opening and closing of the valves takes place inside any four stroke engine, right? So how this ports get opened and closed in case of a two stroke engine? So these ports get opened and closed due to the piston movement only. That means if there is a port, let us assume there is a hole, and if my piston is uh, at this particular port, then in this case we can say this port is being closed, right? And if this piston is moving down right now, then now this port is open, right? So this is how in case of your two stroke engines, your opening and closing of the ports happen. Okay, and there is a special mechanism for opening of valves in case of a four stroke engines, right? Hope I am clear. Sorry. Okay, let me erase this portion. Okay, now next difference we can see, its its engines results in thermal lesser thermal efficiency. Okay, so in case of a two-stroke engines, we will be getting lesser thermal efficiency, and in case of your four-stroke engines, will be getting higher thermal efficiency. Okay, why it is so? So thermal efficiency, as we know, this is something output by input. Any efficiency you can say this is output by input. Okay, so what is the output over here? What is the what we are obtaining? That is the output, and the input is what? What input we are providing? That is the heat. Okay, so in case of your two-stroke engines, what happens? Whatever fuel is being provided to the cylinder, all the fuels cannot be burnt. Sometimes some amount of fuel may go out through the outlet port, right? Exit port we can say. So that this is why we can say whatever amount of heat we are providing, whatever amount of oil we are providing, fuel we are providing, all the amount of fuel cannot be burnt. That is why whatever amount we are expecting heat to be given to the system, that cannot be done. Okay, so if input is being decreased, that means simply you can say we'll be getting less power, right? So this is why you can say uh, uh, the efficiency of the two-stroke engines are less as compared to the four-stroke engines, right? So this is why you can say less thermal efficiency in case of a two-stroke engine, because some amount of fuels are not burning inside that particular cylinder, and that goes out. So some fresh stars are going out. So that is a loss for us. So this is why you can say we are will be having less thermal efficiency. Okay, but if we'll be talking about the power ratio, that means power to weight ratio, then in this case it will be having large. In case of a two-stroke engine, we'll be getting the large amount of power when we'll be comparing with weight, right? So it will be taking same weight of or two-stroke engine and four-stroke engine. Then for the same weight, we'll be getting large power in case of your two-stroke engine. What is the reason? Reason is that there are no valve mechanisms, right? So there is no complicated arrangement, complicated design. So the engine weight is very much low in case of your two-stroke engines, right? So we'll be getting large power to weight ratio in case of your two-stroke engine, and we'll be having less ratio of power to weight in case of your four-stroke, right? Okay. Moving further, uh, next difference we can see that it generates more smoke and shows less efficiency. So that is already we have discussed. So it will be producing more smoke. Why smoke? Because some amount of unburnt products, unburnt fuel, unburnt fuel which has not burnt yet, that will be going out through the exit port, or sorry, exit port. So this is how we can get maximum or more amount of smoke over here. Okay. So in this case, we'll be having less smoke in case of a post-stroke engine. So at least whatever amount of fuel is being provided to the cylinders, that will bond inside the cylinder if there is no any knocking and return distance and all that, right? So if that is not there, then all these fuels will be burnt. So from that case, we can say that there will be less smoke production products, right? And it will be having more efficiency. Okay, so to avoid this smoke formation or the whatever charge, stress charge is going out through the outlet port, so we are doing a process that is your scavenging. Okay, so let me tell about that over here. So what is scavenging? So this is a process by which we are trying to minimize the loss of the press charge, right? So definitely there will be a loss of the press charge. So if there is any process by which we can reduce the loss of that press charge, then that type of process is known as scavenging. How we will be doing that? So we will be making a shape of that particular engine. So let me draw and show how it is being done. So let this is any particular uh, two-stroke engine, and so this is the engine I can say, and here let the piston is now. So piston is at this place. So this is the piston. So let this is the passage which our press charge will be entering to the engine cylinder, and this is the passage which our burning products, exhaust products, will be going in, right? So basically now in this situation there will be some burn products. Now, at this time, both these valves are open, right? So, if in this situation, what will happen? Definitely, this press charge will be entering this to the cylinder, and here the burning products will be going out of the cylinder, right? So sometimes it will happening that this press charge will also will be going towards this, and it will be going out, right? So if we'll be doing some arrangement like this over the piston, then this shape will be trying to push this press charges towards up, so that this press charges will be pushing the exhaust products to move out, right? So this is the process of scavenging over here. I hope it is understandable. So we are making the piston head of different shape, uh, some type of parabolic shape over here, so that the press charge which is entering to the cylinder, it will be pushing the exhaust products to move out, right? So this is the process of scavenging, right? I hope it is understandable. Okay, sorry. So we have discussed till this point. So it generates more smoke and less efficiency. So in this case, four-stroke engine will be having sorry less smoke, and it will be having more efficiency, right? Okay. So definitely in this case of your two-stroke engine, we are getting power stroke in each revolution of the crankshaft. For each revolution, we are getting a power stroke. That means maximum it will be requiring a more amount of lubricating oil. Okay, and sometimes this amount of lubricating oil which we are providing inside any two-stroke engine, that also get burnt inside the engine itself. Okay, so basically we have to provide maximum amount of lubrication in case of a two-stroke engine, right? In case of your four-stroke engine, it will be requiring less amount of lubricant. Okay, we can understand that. Okay, and if we'll be doing the poor lubrication, then there will be wear and tear in the piston, maybe in the piston, maybe in the cylinder, right? So we have to basically focus on the lubrication part. Okay, and there will be less wear and tear occurs in case of your four-stroke engine. Okay, and it will be talking about the cost of any engine, that is cost of four-stroke or two-stroke engine, then simply we can say in case of a two-stroke engine this will be cheaper, right? And it is also simple to manufacture. So it is simpler to manufacture because there is no valve arrangement, right? There are ports only. So ports are something like holes, right? So in the periphery of the cylinder, there will be number of holes, like one or two holes basically, 2 to 3 holes there will be present over the periphery of the cylinder, right? So it will be easy to manufacture the two-stroke engines, but uh, in case of a four-stroke engine, there are the basically valve arrangement, right? So for that, it will be expensive. So engines are expensive due to lubrication and valves and tough to manufacture. Definitely, it will be very tough to manufacture and design also, right? Okay. And in case of a two-stroke engines, these are basically lighter and noisier, right? Noisier why? Lighter we can understand because there are no valve mechanisms. And another thing also we will be talking about the flywheel. There will be uh, a smaller amount or smaller dia of the flywheel is being used, right? So sometimes the flywheel is also not required, right? Okay. So lighter because there is no flywheel. So what is the function of flywheel? We'll discuss. But noisier why? Already we know because during each stroke we are getting, sorry, during each revolution of the crankshaft we are getting power. That is why we can say it is very much noisy. Okay, and this is less noisy, and this is heavier because of the valve arrangement we can say, and we will be requiring flywheel. So with the function of flywheel, it will be talking about any type of engine that may be four stroke or two stroke. Okay, let us understand about the four stroke. Okay, so during all these four strokes, in each stroke we are not getting power, right? Among all these four strokes, there is only one stroke during which we are getting power. That simply means to operate all these three strokes, we need to provide some power to the engine. Okay? So that power is we bring from the flywheel. That means suppose and this is being operated by the application of your Newton's first law. That means any heavy mass is there and we are giving some motion to that particular mass that will keep that particular motion for some duration, some time, right? So this is that principle which we are using over here to run the flywheel or to run the engine. And basically, in case of a four-stroke engine, we are having such type of three strokes, three processor with three strokes, during which we need to provide power to the engine, right? And during only one stroke, we are getting power, and during three strokes, we are providing power to the engine. So that is why we'll be requiring heavier flywheel in this case. Okay? But in case of your two-stroke engine, again during one stroke we are getting power, but to do the next stroke will be have to provide the power right to the engine. So that is why in this case of the two strokes, during one stroke we are providing power, but in case of your four strokes, during three strokes we are providing power. So that is why we'll be requiring a smaller mass of the flywheel in case of the two-stroke engines. That is why we can say this is lighter and this is heavy. Okay, so I hope we you guys understood the basic differences between four-stroke and two-stroke engines. And previously already we have prepared a video which in which we were discussing the basic difference between your petrol and diesel engine, that is the CI and SI engine, right? SI and the CI engine. So if you have not watched that particular video, then also you can find or I'll be attaching that link in the description of this video, right? So keep learning, keep smiling. Okay, thank you for watching.